Hi guys, welcome back. So in this video, we are going to talk about the cities and the land use issues. So here is an outline of this video. We will talk several concepts and the model series, and those model and series are very interesting. Here, first we define land in economics. Land is one of the materials and the forces which nature gives freely for man's aid in land and water, in air and light and heat. And then we are going to talk about how we allocate land. We allocate land depends on the bid-rent curve. Firms produce goods to maximize their profits by choosing where to locate and what factors of production to use. For example, land, labor, capital, and households maximize their utility by choosing how much housing to consume and where to live. We can describe the process by which land prices and land use are determined using bid-rent curve. And in other words, we can use bid-rent curve to determine the land allocation. A bid-rent curve represents the amount of money or amount of bid an individual or firm is willing to pay to be located in a particular location. And in our case, both firms and households have bid-rent curves, but they may differ for firms and households. That is because firms they have different preference for location for land from the households. And due to that, firms have a steep bid-rent curve near the CBD, and the CBD is defined as Central Business District, where most businesses are located in this area. Firms prefer CBD due to several reasons. First, CBD provides easy access to information. And be located in CBD, firms can interact with other firms and the costs are lower. The transaction costs are lower if they are centrally located. Also, firms they may want to decrease the travel cost of workers, and in that way they can decrease the cost on firm's side. But for households, the preference may be different. They have a flatter rent bid curve. Why? Because they are less dependent on immediate access to information and services, and they often prefer to have larger lot sizes, and they are willing to commute. And from this graph, we can see the difference between firms' bid-rent curve and households' bid-rent curve clearly. So the x-axis represents the distance to CBD, and the y-axis represents the land rent. So we can see from this graph, being closer to CBD means that you need to pay more for the land rent, and the firms they are willing to pay more to being closer to CBD. So firms' bid-rent curve is the black one, and the households' bid-rent curve is the red one, because households they don't really care about being closer to CBD or not, and they are willing to commute. But for firms, they are willing to be closer to CBD, and also they are also willing to pay more for that benefit. And the next, shifts in the bid-rent curve. What causes the shifts in the bid-rent curve? There are so many factors can affect the firms and also households' bid-rent curve. For example, the increased gas prices, the congestions, the construction of new highways. So we would use the construction of new highways as an example to explain the shift of bid-rent curve. So suppose before the highway, again the black one is firm's bid-rent curve and the red one is household's bid-rent curve. Their intersection point is here, and the area on the on the left to this intersection point, we call this the firm zone, because firm would be willing to pay more for the land on the left of this intersection. So this area only firms would exist, and this area on the right of the intersection only mostly the households would exist. Why? Because households are willing to pay more than firms for this area. So that is the explanation of firm zone and the residential zone. After highway construction, both firms and the households bid-around curve become flatter because they can pay less for the land, because there is a new highway available which can reduce their transportation cost. So we can say the new firm bid-around curve is the yellow one, and the new households bid-around curve is the green one. Their intersection is here. So the intersection also moves to the right, and the area on the left of this intersection again is the firm zone, because in this area firms, they are willing to pay more for the land than the households. And the area on the left, on the right of this intersection is called the residential area, because households, they are willing to pay more than firms for this land. The next model we are going to talk about is Wong-Sonnen model. And this model can help us to understand why do farms grow what they do. Wong-Sonnen was a landowner and economist. He developed the first economic model of spatial land use. And the key insight from his model or his theory is that the same land may be used differently depending on access to market. So the next concept we need to use to determine the spatial land use is the location rent, which is defined as the price of accessibility to the market, holding land quality constant and only consider the transportation costs. And the net rent is the value of a commodity after production and the transportation costs. So from Wong-Sonnen's theory, we need to grow the highest value crops on the land with the highest location rent. And let's see this graph to understand this conclusion. And let's consider a single product, wheat. So first, when farmers, they live far away from the market, then that means they need to pay more for the transportation cost. And that also means their final profit, the difference between total revenue and total cost, would decrease. So then we get a conclusion. Transportation costs make wheat less profitable farther from the market. Or we can say the economic rent decreases due to the transportation cost. And from this graph, we can say the area of wheat production is under the yellow curve, and this is the only area that is profitable for wheat production. And farther away from the CBD, there would be no profits for farmers to produce wheat, because they have to pay more for the transportation, and the difference between total revenue and the total costs would be negative. So the y-axis again represents the economic rent. When being closer to the CBD, the difference between revenue and the cost would be greater, and that also means the amount that farmers can pay for the landowner would also be greater. So that also means the economic rent for being closer to CBD is largest at this point. Then we have several assumptions. Assume all land is equally productive and assume all crops are sold in a central market. Production costs and prices are constant for the product, and that means there is no returns to scale. And then we consider 3 products: tomatoes, peas, and wheat. Each crop has a different bid rent curve because the value of crops are different, and so are the transportation costs. So as a result from this theory, we will grow the high rent crop closest to the market. The higher the transportation cost, the steeper the bid rent curve, and the higher the crop value, the higher the vertical intercept of the bid rent curve. So those 2 sentences are very important, and it helps us to determine the bid rent curve for each crop. And here I have a question: which of these agricultural goods is typically the hardest to transport? The first one is tomato, second peas, and third wheat. So the correct answer is tomato. Comparing to peas and wheat, tomato is the hardest one to transport because it is much larger than peas and wheat, and also it is easy to rot. And here is a graph showing the bid rent curves for tomatoes, peas, and wheat. And as we can see from this graph, we will grow the highest rent crop closest to the market, and we draw those 3 lines according to those 2 terms. The higher the transportation cost, the steeper the bid rent curve. And we already know it is hardest to transport tomatoes, and that also means the transportation cost for tomatoes would be the most expensive one in this case. So that means the bid rent curve for tomatoes would be steeper than that for peas or than that for wheat. And according to our second sentence, the higher the crop value, the highest the vertical intercept of the bid rent curve. Because tomato is the most expensive one among those 3 products, so that means the intercept of tomatoes bid rent curve would be the highest one. Also, by comparing the transportation cost and the market price for peas and wheat, we can plot their bid rent curve respectively on those graphs. The green one represents peas bid rent curve, and the yellow one represents wheat bid rent curve. And here is one sentence original example. The black dot in the middle just represents our city, and the right circle represents the dairy production, and the green one represents our forest. The yellow one represents greens and field crops. The outside one, the red one, represents ranching area. And here is a formal treatment to the model. We first need to define some concept. P is the price of crop. T is the cost of transportation. D is the distance to market. And L is the land used for production. Q is the quantity of crop produced. So according to those definitions, our revenue is P minus T times D. P is the price of crop. T times D is our total transportation cost, and times the quantity of crop. That would be our total revenue. And the cost would be equal to C, and C is our production costs, includes wages and other production process costs. Then the profits would be the difference between total revenue and the total costs. So we just do a simple calculation here. This formula just represents our total profits. And if we want to optimize wheat production, here are several assumptions. And then I want you to calculate how much profit would you make producing wheat on 1 acre at a distance of 1 mile. And remember this function, we use this function or we use this equation to calculate the profit. It is just the difference between total revenue and total costs. The total revenue is the first term, including the transportation cost, and the total cost is the second term, including our wages and other production process cost. And according to our assumptions, wheat sells for $5 a bushel, an acre planted results in 10 bushels. Costs of planting an acre are $1, and the transportation costs are $2 a mile. Then P is equal to 5 because the price for wheat 1 bushel is $5. And T times D, T is 2 because the transportation costs are $2 a mile. D is our total mile, and the distance is just 1 mile. So P minus T times D, which is equal to 5 minus 2 times 1. Then we need 2 times the total quantity of our wheat, and the total quantity would be equal to the production from 1 acre and the total acre. So the production from 1 acre is 10 bushels, and we only have 1 acre, so the quantity is 10. Then our total revenue is just equal to 3 times 10 is 30. The cost would be cost of planting an acre at $1. The cost would be equal to 1. Then our total profits is the difference between those two terms, which is 29. Okay, so next person we are going to talk about is David Ricardo. He is the son of a stockbroker who lived from 1773 to 1822. He helped develop the theory of economic land rent, especially as it applies to agricultural uses. And his model of economic land rents is strongly related to opportunity cost. And here is his theory regarding land rent, which is the value of difference in productivity between parcels of land producing the same good under the same conditions, and those conditions include labor, capital, technology, and so on. A key insight of his work is the concept of land productivity. So he mentions that not all land is the same, and what determines land's productivity. Ricardo identifies several features which determine the productivity of land, and here are several assumptions he made. First, there are fixed input and output prices. There is zero profit for farmers. The highest bidder is allowed to produce on a parcel of land, and we need to ignore the transportation costs. In his theory, the owners rent their land to farmers. So here is an application of his model. Suppose there are 3 different qualities of land corresponding to low productivity, medium productivity, and high productivity. Farmers can produce the same amount of corn with fewer inputs on fertile land compared to less fertile land, and because of increased production, prices of the fertile land are higher. Profits are given to the landowner in the form of a rent, and the income of the farmer is considered a cost, which is similar to a wage. Here are the results from Ricardo model, and basically we just want to compare the profits for farmers from different lands, and we will start from the first graph. The market price for corn is $6, and the marginal cost is this line. The average total cost is this line. The intersection of marginal cost curve and the market price is our market equilibrium. So for the first graph, here is the intersection, and the corresponding quantity is the optimize the corn production. So for the first graph, here is 500, and the area under the market price is our total revenue. And when we connect the market equilibrium point and the equilibrium quantity, we connect those 2 points, and we have this vertical line. The intersection of this vertical line and the average total cost represent our production cost for 500 corns, and this area 2 times 500 represents our total cost of production. Then the difference between total revenue and the total cost is farmers' profit from the production. And according to Ricardo corn model, the profits are given to the landowner in the form of a rent. So we can say the rent is also equal to the difference between total revenue and the total cost, which is 2,000 in the first graph. Then we move to the second graph. Again, the market price for corn is $6, and the intersection of marginal cost curve and the market price is our market equilibrium. The corresponding quantity is corn production. So we can say from the comparison of first graph and the second graph with the same input, the less fertile land just produces less amount of corn, and the total revenue for the less fertile land is just the area under the market price curve. The total cost, first, to find the total cost, we need to connect the market equilibrium point and equilibrium quantity, and then the intersection of this vertical line and the average total cost is here, and we find the corresponding price, which is our production cost for per unit. Then our total cost is 4 times 300. The profits from the production would be the difference between total revenue and the total cost, which is also $600. And given the definition from the model, profits are given to the landowner in the form of the rent. So that means the rent of the land is equal to $600 for less fertile land. And let's see the third graph for the non-fertile land. For this one, the average total cost curve, the marginal cost curve, and the market price, those 3 lines, they just intersect at the same point. And that means our total revenue is equal to total cost, because total revenue is the area under the market price, and the total cost is the area under the average total cost curve. And as we can see, the total revenue and the total costs are exactly the same. That means the profits are 0 for non-fertile land, and that also means the land rent is equal to 0 for the third graph. Here is the conclusion. The more fertile land has lower production costs and therefore receives higher rents, because farmers, they receive higher profits from more fertile land. And in the equilibrium, rents are identical to profit because there is a perfect market for land rent, and this just beats away the profits that the farmers get from those lands, and finally they get 0 profits and the landowner gets all surplus value. Here I have a question. Assume that the Ricardian model is correct. Will farmers have any preference over which land to use? And the correct answer is no. Farmers would have no preference over which land to use, because finally their profits would be 0 and all surplus would be given to the landowner, so they will have no preference over the land. Here are some exceptions. If there is restrictions on entry or on computation, then the landowner's rents would not be equal to the total profit. For example, if farmers they have a patent to reduce their production costs, then the landowner cannot charge additional rents reflecting the gains from the patent, because no one else would be willing to pay such high rents. Then we are going to talk about the recurring patterns in cities. And basically, we just compare three common patterns. The first one is called a monocentric city. The second one is called a monocentric city with suburbs. And the third one is called a polycentric city. These patterns often coincide with the age and the size of the city, and early models of land use sought to explain these patterns. More recently, a wide variety of patterns has emerged, which these early models of land use can help us to understand. And the first one is the monocentric city. It is the one in which all economic activities occur at a single CBD, and the CBD again is Central Business District. The CBD is the commercial center of the city, and the monocentric city, as shown in this graph, there is only one CBD. This map can show us what is monocentric city, like the example in Birmingham in Texas, and there is only one CBD and no other CBDs. So that is an example of monocentric city. Then we are going to talk about firms in a monocentric city. For small cities, as we mentioned before, there is only one CBD and it is enough. And there is a zero condition, which implies rents increase as transportation costs decrease, which also means rents increase as one is closer to CBD, and the land prices are highest in the CBD, which can be shown in our first graph. And as cities become larger, and it forces some economic activity further away from the CBD. And my question is that who remains in the CBD? The answer for the question is that only firms can remain in the CBD because they can get easy access to information, and they can interact with other firms, and the costs are lower if they stay in CBD. And they also want to decrease the travel costs of their workers, so their willingness to pay for the CBD would be higher than households. That answers our question, and the theory also explains the distribution of firms and households in the city. Then we are going to talk about the households in a monocentric city. Households are attracted to CBD because commuting costs are less, but a household's budget consists of commuting cost and land cost. Households, they face trade-offs between location and house prices, and this line represents demand for housing near the CBD. And as we can see, when we are getting closer to CBD, the price for the housing is increasing dramatically. So for households, they may have a flatter build rent curve because they are willing to pay more for commute, and they are less dependent on immediate access to information and services. They often prefer to have large lot size and so on. So comparing to firms, households may located outside of the CBD. Then we are going to start our second patterns of city, the monocentric city with suburbs. As the city grows and land prices increase in the CBD, households began to settle further away from the CBD. And why is economic activity still centrally located? Because according to this pattern, this so-called pattern, households, they can pay less for the services or other informations in the CBD. So that explains why economic activity is still centrally located. And here is an example of monocentric city with suburbs, the State College in Pennsylvania. And the emergence of more distinct subdivisions creates the needs for new public services, like public schools, like the highways, roadways, public parks, and recreation areas. Then our government takes a great role in determining the growth patterns of cities because they are deciding the local zoning laws and the public infrastructure. And at this stage, many communities need to raise money to supply amenities. Then we jumped to our third city pattern, the polycentric city. As cities become even larger, increased commuting costs and congestion result in many new, smaller CBDs around the original CBD. So as we can see, this larger circle represents the original big CBD. However, when the city is getting bigger and bigger, there are more smaller CBDs around this original CBD. And in many cases, this can lead to a decline in inner city. The yellow circle just shows the decline in inner city. And here is an example of polycentric city. The largest circle just represents the original CBD, and those smaller one just represents the CBDs after the original one, just because the city is getting larger and larger and cannot afford everyone's need. The next topic is Zipf's law, and in this slide I explain who is Zipf and what his contribution is. He analyzed how frequently we use words and ranked them in order of popularity. The key insight of that is that the number one ranked word was always used twice as often as the second ranked word, and 3 times as often as the third ranked, and so on. For example, is the most frequently used word, accounting for 7% of all word occurrence. Of is the second often most used word, with 3.5% of all occurrence. And in this slide, we apply Zipf's law to our city patterns. The city with largest population in any country is generally twice as large as the next biggest city. So as we can see from this table, the population for New York City is twice as large as the Los Angeles. And Zipf's law does not hold for cities with less than 100,000 populations. And when we compare the population of cities, it doesn't matter you use the political definition of city or the natural definition of city. However, there is no economic intuition to explain why this phenomena is happening. And the last theory we will cover in this video is central place theory. It explains how the location patterns of different industries combine to form a regional system of cities. And there are 2 assumptions behind this theory. The first one is that production exhibits economics of scale, and the second one, economics of scale relates to per capita demand. For example, the brain theory, it satisfies the needs of populations in a very large area. And here is an example of central place theory. Assume a region with the following characteristics. The initial population density is uniform with total population of 80,000, and there is no shopping externalities. and the inputs are everywhere. There is uniform demand, and people just consume 3 products. First one is books, then pizza, and then jewelry. For jewelry, every store requires a population of 8,000, and for books, every store requires a population of 20,000. For pizza, every store requires a population of 5,000. And from this graph, we can see for small cities, only 1 pizza store is enough, and S just represents the small city, and every pizza store requires a population of 5,000, and M city, just the M, the circle M represents M city. It requires bookstore and 2 pizza stores. The city large city requires 1 jewelry store, 2 bookstores, and 4 pizza stores, and the total population is 80,000. And here are some symptoms of central place theory. First, density and scale economics. Different scale economics relative to per capita demand. And large also means few, because when there are few large cities, that means there may be more small cities. And shopping passes. Consumers, they will travel to bigger cities, and cities of the same order do not interact with each other. And there is also limitation of central place theory, which is that it only focuses on consumer goods and it ignores the role of local inputs like local labor and local materials. And here is the reference for this video. I mainly talk about the city patterns and the land use.